Hello everyone, welcome back to another video in the ACSL short problem series. Right now, at the current time that I'm making this video, it's actually getting kind of close to ACSL registration time. So it's around October right now. So for those of you who are looking at this video at the time I'm publishing it, that's something to keep in mind for if you're either part of my class or your school is offering ACSL. So keep an eye out for that registration. Anyways, today's video is bitstring flicking. So let's look at it. First of all, let's talk about some of the bitwise operators. These are the operators you're going to be using. I notice I don't have a definition slide this time because I'm just kind of explaining there's not much definitions with this. It's mostly just a new set of operations you have to learn with binary numbers. These bitwise operators are also used in programming. They usually don't look like this. This is just when you're writing it, and I think this is for math. The main types of operators you have are the unary and binary. And the unary operators, it just means it takes one value, and binary operators takes two values. I think of this as like if operators were functions and unary operators would take one parameter and binary would take two. So for example, there's the not, which is actually the only unary operator we're going to be learning about this time. This not operator shows up looking like that thing, or sometimes it just types out not in ACSL problems. What this not does is it'll flip each of the bits. Okay, let me clarify that when we're doing this topic, bit string flicking, we're going to be working with strings of bits, so ones and zeros. And flipping a bit is going to make zeros into ones and ones into zeros. Like you see here, a not of 1 is equal to 0, and the not of 0 is equal to 1. So it does look kind of like a function. It works kind of like a function too. Except if you're going to have a not of a complex string that's not just a singular 1 or a singular 0, then it's going to flip every single one of those digits. And so for example, our example here is 0, 1, 1, 0. And what this not will do is it'll flip each of the individual bits and basically combine into one string. And some of our binary operators here, you can see AND, OR, and XOR, the main ones. There's also NAND, NOR, and there's also XNOR actually, but most of the time those are just combinations of NOR and AND. Not NOR, not and AND, not and OR, not and XOR. So these four are really the most basic ones. XOR you could think of as a combination of these three, not, and OR. So let's talk about this. AND is a binary operator. For each bit in both values, it'll output 1 only if both are 1, output 0 if otherwise. This means if we're continuing the function analogy, if you have 1 and 0, that'll be 0 because one of the parameters is 0. And if you have 1 and 1, it'll be 1 because they're both 1. So for this example here, if we take the AND of these two strings, it'll compare the first two. Now let me get my annotation tool. It'll take the first two digits, compare them. They're both 1, so that's why we have a 1 here. And then the next two, so this is a 1 and a 0. And since there's a 0 here, we're going to output a 0 here. You're going to notice the rest of our strings is zeros, and we can double check this. So 0 and 1, 1 and 0, and 0 and 1. So each of those pairs had a 0 in it, which is why we had a zeros for the rest of our string here, for the rest of our answer. For OR, I put in the definition for each bit in both values, it'll output 1 if either bit is 1, and like this is two separate conditions. It'll output 1 if either bit is 1. It'll output 0 if both are 0. This is almost the opposite, or like inverse. You can think of it as inverse of AND. For example, here we'll take a look at the first two digits of these two strings. One of them is 1, which is why we have a 1 in our answer. Here it's a 0, but here we have a 1, so we'll have a 1 here. And then you notice for this third bit, we'll have zeros in both of these values, these strings. So we'll have a 0 in our result. And then the rest of the two, this one has a 1, So that'll become, we'll put a 1 here. We don't even have to check if that one has a 1 or not. I mean, we could, but it's redundant since there's already a 1. And then this one's a 1 too, so we'll put a 1 here, and then this last one is also a 1. For XOR, it's a little bit more complicated. What XOR does is for each bit in both values, it'll output 1 only if one value is 1 and the corresponding bit in the other value is 0. So basically, it has to be either 1, 0, or like 0, 1 in order for the result to be 1. I'll put like XOR here of this combination or of this combination to be 1. Of course, it'll end up looking like that. I'm not actually writing in the correct terminology. But if it's XOR of either 0, 0, it'll still be 0. If it's XOR of 1, 1, it'll be 1. I mean, it'll be 0, sorry. So let's look at this in an example. Let's compare the first two digits here, 1, 0. For XOR, you're going to have to look at both of the digits because it has to be that both of the digits are kind of... this is when you have a dependent result. So 1, 0, this will produce a 1. This is a 0. So in order for the next digit to be 1, the corresponding digits must be 1. And then this 0 and this is 0. So since both of them are the same, we're going to have a 0 here. I forgot to underline this earlier. For this one to be 1, since this is a 1, this must be 0, and it is 0, so we're going to have a 1 here. And then you can see that the last two are 1. It's the same value, so we're going to have a 0 here. Okay, now that we've gone over the operators, let's take a look at some practice problems. So first of all, let's take a look at the following. Evaluate a knot of, and then you can read that on your own, but I'm just going to go over this, pause if you need time to work on it. First of all, I'm going to rewrite the problem. Actually, I don't need to rewrite parts of it. But for this part, I can just solve this knot of 1, 0, 1, 1, 0. You could like position it below the words to make it a little easier to look at. I'm going to flip each of these bits. So it's going to become 0, 1, 0, 0, 1. And then this is where I rewrite part of the problem or copy it down. Whoops. And then we're going to perform OR on here. So the first two are 1. And then the rest of these are 0s. So I'm just going to check the rest of the numbers here. And then I see that this is 1, 0, 1. So I'm going to copy that over since there's no way that we're going to have a 1 from any of these digits. And now let's perform our final calculation. So the one end of this, the trick I use is to see which one has more zeros and then copy down the positions with zeros in that number and then go over to this side and see if it has, I should copy down that blank space, see if it has any extra zeros. And it doesn't, so I'm just going to fill this with 1 and this is going to be our answer. So for the next one, let's do the same thing here. Knot of 1, 1, 0, 1, 0 is going to be 0, 0, 1, 0, 1. And then we're going to take this, the OR of this, and XOR. Here we're going to have 0 for the first digit, 0 compared with 1, which is just 1. 1 compared with 0, which is 1. 1 compared with 0 is 1. 0 XOR 0 is 0. And now we're going to OR this. Kind of same trick with AND. I'll see which one has more 1s and then copy down the digits here and leave spaces where there could be other possible ones and go back to the second or go back to the first value in this case. And I'm going to see that it also has a 1 in the last position, but it has a 0 here, so this is going to be 0. And this will be our answer.